Hi, in this video, I will be showing you problem number 4 of chapter 12, section 4. Find the cross product of vector A cross vector B and verify that it is orthogonal to both A and B. Vector A is equal to 3i plus 3j minus 3k and vector B is 3i minus 3j plus 3k. So let's find out the rule for finding the cross product of two vectors. So the formula for A cross B, where A is given by A1i plus A2j plus A3k, and B is given by B1i plus B2j plus B3k. We have a way of doing it. So let's take A in the 3 rows and 1 column matrix form, and then B has 3 rows and 1 column matrix form. Then we have to do A cross B, which is the 3 rows, 1 column by 3 rows, 1 column. So in order to do that, we actually take a rule. So we first hide A1, the first row, then it is second A2 times B3 minus B2 times A3. And then for the middle, we have to actually switch the sign, then it will become A3B1 minus A1B3. Then for the third, hide the row, then it is A1B2 minus B1A2. The important thing that you have to note is that in this part, we are actually changing the sign, which is the j component. The first one is the I component, this one is the I component, and this one is the j component, and this one is the k component. So only when you write the j component, you are actually hiding the second row, and then you're switching the thing. Normally it is left to right. In this case, we have to go from A3B1 minus A1B3. So that is where the sign changes. So keep that in mind when you do the cross product. Cross product is a vector, so it will have an ijk component form. So now we write A cross B as A2B3 minus A3B2I, then plus j A3B1 minus A1B3j plus A1B2 minus A2B1k, which is in the ijk component form. So this is the formula. So this is what we are going to use for RA. This is A1, A2, A3, and this is B1, B2, B3. So we are going to do A cross B for the given vectors A and B using the formula we just discussed. B is 3i plus minus 3j plus 3k. So A cross B is the determinant where the first row is ijk and the second row is the components of A and the third row are the components of B. So if you use the formula that we just discussed, that is 3 times 3, then minus of this times this, negative 3 times negative 3, and then that is the I component. Then for J, we said that you have to switch the sign, so it will become negative 3 times 3 minus 3 times 3. Then for the k component, it is, you have to hide the column and the row to which k belongs. So it will become it will be here 3 times negative 3 and then minus 3 times 3. So if we complete that, it will become 9 minus 9 times I plus minus 9 times j plus minus 9 k. So it will become 0i minus 18j minus 18k. That is A cross B. So in this, now we are going to actually also, in the second part of the problem, we are going to show this A cross B is actually orthogonal to both A and B. So two vectors are orthogonal if their dot product is 0. So two vectors are orthogonal, let's say C and D are orthogonal if their dot product C dot D equal to 0. In order to do the dot product, you have to multiply the corresponding components and add. In this case, it is C1 D1 plus C2 D2 plus C3 D3 equal to 0. That is what we have to show. So let's try to do that part here. To verify that A cross B is orthogonal to vector A and vector B, we have to show their dot product is 0, which means that we have to show A dot A cross B is 0, and then B dot A cross B is also 0. So let's do first A dot A cross B, which means that we have to multiply the corresponding components and add, and the result should give us 0. So it is 3i plus 3j minus 3k dot product with the components of A cross B, which is from the previous part that we did, negative 18j minus 18k. Then we are going to compute this dot product, which will be 3 times, there is no I component here, that will be a 0. Then 3 times negative 18, negative 3 times negative 18, that product should be equal to 0. So 3 times 0, 3 times negative 18, negative 3 times negative 18, obviously it is equal to 0. This tells us that A cross B is orthogonal to vector A. Similarly, we have to show that A cross B is orthogonal to vector P. So we consider the dot product, which is 3i minus 3j plus 3k dot product with negative 18j minus 18k. This also gives us 3 times 0 minus 3 times negative 18 plus 3 times negative 18, which ends up as 0. So this tells us A cross B is orthogonal to vector B. And here you note how we find the cross product of dot product of two vectors. If A has components, if A is A1i plus A2j plus A3k in the component form, and B is B1i plus B2j plus B3k, then A dot B would be equal to A1B1 plus A2B2 plus A3B3. Notice always that A dot B is a scalar and A cross B is a vector. Okay, keep that in mind. This is a scalar and A cross B is a vector. Hope this video helps.